Oh god, let's see if anybody studied for this test. Okay, okay. Let's see. Watched a YouTube video. That was an hour long. Okay, but he used an app that shortened it. Okay, let's see what Nutshell is about.
Most of the Sacramento City Unified School District's 46,000 students live in low-income families, and about 72% of them qualify for free or reduced lunch. In some neighborhoods covered by the district, as many as 1 in 4 households don't have broadband subscription. With the majority of Sacramento students experiencing spotty internet, glitchy devices, and piling responsibilities, it's needless to say that learning from home has been difficult. With this in mind, our team thought, what if we created a solution that makes learning from home easier, more efficient, and accessible, not just for those in Sacramento, but for everyone? And so, we created Nutshell.
Imagine this, you're 5 lecture recordings behind in your virtual class, and your midterm is in a couple of hours. You convince yourself that watching 5 hours of lecture in 2 hours would definitely be possible, but you realize that even 2 times speed can't save you now. There's still too much information in each video, and you just want to hear the key points. Nutshell gives you the ability to do just that. You can shorten a given video to a user-selected percentage of the length of the original video in a single click. The front end was made with React, while the back end was made with Flask, PostgreSQL, sklearn, and a bunch of other GCP services, such as Memory Store, Compute Engine, and Speech-to-Text. We also used IBM Z to quickly and easily train a machine learning model to predict the amount of time Nutshell takes to run on a video. Starting with the home page, the user is presented with an input form to enter a YouTube video link. After clicking next, the user is asked how much of the video they want to see, which they are able to adjust via the input slider. This slider represents the approximate percentage of the original video preserved in the final output. After submitting the form fields, the user is redirected to the loading screen, where they are able to see the different loading stages of the summarization process. With the help of socket.io, the user can receive real-time, live updates on the status of their video. When the process is done, the user is redirected to the video screen, where they can see their shortened, summarized video as well as supplemental data regarding the video. The Overview tab lets the user easily digest content about the key sections mentioned throughout the shortened video. Here, the user can go through the different key sentences and jump straight to their timestamp in the video above. The Details tab also gives more information to the user regarding their video, such as the video's reading level over time, as well as how much they were able to cut down their video by. In the case that the user enters a video that was already shortened by Nutshell, instead of waiting the loading screen as they normally would, they are able to jump straight to the final video screen. This is because previously shortened videos are cached and can be instantly retrieved. As you can see here, the user is informed about why the process was able to complete so quickly. Before we talk about the video generation steps in detail, let's start off about how we used IBM Z. We used IBM Z to train a regression model to predict the amount of time a video would take to process, given the duration of the input video. We had to do this because each video would take anywhere from 2 to 6 minutes, based on the length of the video, with most of the time being taken up by the call to the Google Speech-to-Text API, which is out of our control. Predicting this allows us to show the user an estimated time to completion, which results in a better user experience. Behind the scenes, we actually perform a complicated series of steps to produce the final output. First, we download the video from YouTube. Then, we demux the video, splitting apart the video and audio tracks, and transcode it to FLAC. Next, we upload the audio to a Google Cloud bucket, which then allows us to pass it to Google Speech-to-Text, converting it into sentences with timestamps. We then take these sentences and run an extractive summarization model on it, which finds the key sentences in the text, where the number of sentences depends on the percentage the user selected earlier. These sentences are then converted back to video snippets using the original video and timestamps we retrieved earlier. Then these snippets are concatenated together using MoviePy and FFmpeg to create a video. We also take snapshots of this video to use as thumbnails for the user guide. Finally, we also collect a plethora of stats about the video with information like average reading level for each minute, overall estimated read time, and time savings the user got from using Nutshell.